Welcome to the final notebook of this section, Notebook 35, Chatbots. In this notebook, you're going to learn how to leverage explicit message use to store conversation history and thereby enable simple chatbot functionality in your LLM-based chains. By the time you complete this notebook, you'll understand the core principles and techniques that are required to create chatbot applications, specifically those that are capable of retaining conversation history. You're going to actually create an easy-to-use chatbot capable of assuming a variety of different personas. And you'll also have a chance to interact with a simple chatbot application interface, which we would just want you to know about, that's really well suited for chatbot application prototyping. Per usual, we'll make our imports. You can see nothing fancy here. We'll instantiate our LLM instance. And before we can really begin our work enabling conversation history and chatbot functionality, we want to introduce a new kind of message that we haven't covered yet called a placeholder message. It's really worth mentioning that unlike a system message and an AI message and a human message, a placeholder message is not a kind of message that the model was introduced to during its instruction fine-tuning. Rather, a placeholder message is a LangChain construct that we can use basically, again, kind of as a syntactic sugar or kind of as a helpful tool for being able to provide different kinds of messages in our prompt templates, just in a more elegant way. You'll see how it works. It's pretty straightforward. So yeah, put simply, and as the name suggests, a placeholder message is used in a prompt template to hold the place of a list of other messages. So here we're going to create a prompt template called template with placeholder. We'll be using chat prompt template from messages as we've done a lot. And this time, the first message that we're specifying, we're going to indicate that it is a type placeholder message. And then we're going to parameterize the content for this message in a value called messages. As our second explicit message, we'll create a human message, which we will parameterize with a prompt. Okay, now there's no LangChain going on here. We're defining a Python list called messages. This is going to be a list of two tuples, which should start to ring some bells about what we might use it for. And we've got human and AI messages showing a brief conversation between a human and an AI. Furthermore, we're going to define a main prompt, which is what happened today. Okay, now it's worth noticing, again, it's kind of, as we often do introducing techniques, it's kind of a silly example, but it looks like the sun came up today and the sun went down today. And based on these messages, those would be the two things that we would expect to have happened. Okay, so when invoking or streaming or batching prompt templates or chains or other runnables that contain placeholder messages, right? Which again, we have defined a placeholder message here in our prompt template. We provide a value as the template indicates, right? In this case, it'll be a messages value. However, in the case of a placeholder message, we provide a list of other messages rather than a string. Okay, so here we're going to invoke our template with placeholder, right? And we will pass in for messages, which again is a placeholder, instead of passing in something like a prompt, which is what we're doing here, which is just a Python string. For messages, we are passing in a list of other messages, okay? So as you can see, when we invoke this, that LangChain expanded the placeholder message for which we provided a list into a list of individual messages that we provided when invoking the prompt template. So here's the human message, the sun came up today, the AI message, that's wonderful, the human message, the sun went down today, the AI message, that's also wonderful, and then our final human message, what happened today, okay? So put simply, placeholder messages are just a simple way to hold the place of a list of other messages. And the key difference between the human, the AI, and the system message is that when we invoke either our prompt templates or our chains that include prompt templates, rather than pass in a string for a placeholder message, we need to pass in a list of messages. It should come as no surprise at all that we can use this prompt template in a chain, which we'll do here. And then when we invoke the chain, here we're passing in the messages as well as the prompt. We can see that we get a response. It seems like you're describing a typical day. The sun is rising and setting, et cetera, et cetera. Okay, so with that tool at our disposal, it's going to be really straightforward to get started with this idea of conversational history. We can easily construct a rudimentary conversation history mechanism using message placeholders. First, we're going to create a prompt template that utilizes a placeholder and use it in a simple chain. Okay, so we're going to call this our chat conversation template. It's got a placeholder and that's it. You can see we're going to call this chat conversation. We're going to create a chain, which we're going to call chat chain. And next, we're going to create a list, okay, a Python list that's called chat conversation. So let's begin by appending our first prompt as a user message to the chat conversation list. Okay, so here's our Python list chat conversation. We're going to append an item to it. The thing that we're appending is a user message. In this case, we're saying, hello, my name is Michael. So just to test this out, we can now invoke our chat chain with the current chat conversation list. Okay, so here's our chat chain. You remember it expects a chat conversation parameter. And here we have our chat conversation list, which we are providing. So again, we're just kind of exploring a basic setup here and sort of sanity checking that everything's working just fine. The AI is responding with an AI message. Hello, Michael, nice to meet you. All right. So since we're wanting to keep track of the conversation history, however, let's invoke the chain again, but this time append the response to the chat conversation list as an AI message, right? So here we invoked the chat chain, we got the response back, but we didn't do anything to capture the response. So we're going to make that same invocation, but this time we're going to capture the response in a variable, and we're now going to append the response, right, as an AI message to our chat conversation list. So if we look at our chat conversation list now, you can see that it's grown a little bit. We have two items in it. The first is our initial user method, and the second item is the AI message where it responded in a friendly manner. So now let's repeat this process, right? We're going to do the same thing again. We have a prompt, another user prompt. We're asking this time, do you remember what my name is? And just to kind of follow this format that we're exploring, we're going to go ahead and first append our message to the chat conversation. And then we will invoke our chain with the entire chat conversation. We'll take that response and we'll capture it in a variable and append it as well to the chat conversation. And then in this situation, we'll go ahead and view the entire chat conversation after the final response. And here it is. My name is Michael. Hello, Michael. Here's our new prompt. Do you remember what my name is? And the AI says, your name is Michael. I'll remember it for our conversation. How's your day going so far, right? And this makes sense, right? Because the prompt that we're passing in, namely chat conversation, is an ever-growing list of user AI interactions that capture the actual conversation that we've already had. Therefore, the model knows when we ask it something new, like in this example, do you remember what my name is? It does know that your name is Michael, right? Because we provided the previous conversation as part of the prompt. Now, it's worth mentioning here that there's actually a little bit of hallucination happening in this final response. The model says, your name is Michael. I'll remember it for our conversation. How's your day going so far? Now, in fact, if we were not providing the LLM with the entire history of what it had already said in this conversation, it would have no way to remember the conversation. There's nothing about a large language model that stores memory of the other kinds of responses it's already generated. Does that make sense? But here we're providing it with the conversation history that's ever growing, and thus we've enabled an ability for the model to quote unquote remember what's gone before. It's not actually remembering what's gone before. We're providing what's gone before as part of the prompt. Okay, so at its most basic level, anytime you see chatbot functionality where the functionality is such that the AI seems to remember the conversation that you've already had, under the hood, it's basically using this method in some form where it's actually passing in the prior conversation as part of the input to the next stage in the conversation. So just to make things a little bit easier for us, we can encapsulate the functionality that we just walked through, where we're manually making the list and appending to it, and capturing the response and saving it to the list, and etc. Right? We can basically create a Python class to make this kind of interaction much simpler. So if we check this out, it's nothing too fancy. In the init method here, we're going to create a chat conversation template that has a single placeholder value called chat conversation, just as we did previously. Every instance of this chatbot is going to have a chat chain, which is the template LLM and output parser. And every instance of this chatbot is also going to have a chat conversation list. We will define a chat method that expects a string prompt. And just as we were doing above, every time a prompt is passed in, the first thing we'll do is we will append that prompt as a user message to our chat conversation, after which we will invoke the chat chain with the entirety of the chat conversation, take that response, store it in the conversation history, and then in the case of our chat message, because the users of this are going to want to see the actual response, we will return the response. As a matter of convenience, we'll also define a clear method that will allow us to clear the chat conversation list if we would wish. Okay, so all our chatbot currently expects is an LLM instance. So we will create an instance of our chatbot called lowercase chatbot, passing in our LLM instance. Excuse me, I need to define our chatbot class. And now we can utilize the chatbot's chat method. So let's print, hi, my name is Michael. Hi, Michael, nice to meet you. I just want to be reminded of my name, please. Your name is Michael. Tell me interesting, something I probably don't know about pi. Okay. Well, this is probably interesting. We won't read it really here. But now the point being, that's really cool. Give me another what? Well, you and I know we want another example of something interesting about pi. We're not spelling that out explicitly, but because we're actually under the hood passing in the entire conversation history, it knows that what we're referring to when we say another is another interesting example or interesting fact about pi that I probably don't know, which you can see it's doing here. It's also making it a point to use our name Michael again, which is really cool. Okay, so now you've got a really simple way to construct chat classes. Now, it's definitely worth pointing out that